Hi everybody! In this video, we're going to talk about a type of special right triangle that has sides which are all positive integers. These sets of side lengths are called Pythagorean triples. As we know, the Pythagorean theorem states that if we square the lengths of the two shorter sides of a right triangle, the two squares will add up to the square of the longer side, or hypotenuse. Then we can find the length of the hypotenuse by taking the square root of the sum. Here, on the right side of the screen, is a geometric illustration of what this means. Textbook authors and test makers often find it convenient to use triangles where all three sides are whole numbers. There are an infinite number of such triangles, but 2 or 3 basic examples and a couple of related cases are the only ones most people will ever encounter. Let's get started. These 3 basic examples are the 3-4-5 triangle, the 5-12-13 triangle, and although it's less common, the 8-15-17 triangle. The relationships within these sets of 3 numbers will still hold if you multiply all of the side lengths by the same amount. So, for example, you might see a 6-8-10 or 9-12-15 triangle, but those are just scaled up 3-4-5 triangles. You might want to pause the video here to make sure you are comfortable with these calculations. If we train ourselves to spot these triangles when they come up in textbooks or on tests, we will usually be able to see a shortcut. Let's look at a couple of examples. We might be given a triangle like this and asked to find the missing side. Of course, we can do this by substituting into the Pythagorean theorem and then solving for the unknown side. But if we recognize this as a 3-4-5 triangle that's been scaled up by a factor of 2, we can know immediately that the answer is 8 without having to do any calculations. Or we might be studying trigonometry, and a question tells us that the sine of an angle is 12/13 and asks for the cosine. We could do this by using a calculator to take the inverse sine of 12/13 and then the cosine of that. But in addition to requiring us to enter a bunch of stuff into our calculator, we're going to get an inexact decimal answer, and on a multiple choice test, we would have to do even more work to match that up with an answer choice. On the other hand, if the numbers 12 and 13 in the context of a right triangle tip us off that the triangle's other side has to be 5, we can spot the right answer almost immediately. So, knowing the 5 or 6 ways that these triangles commonly appear in an educational setting can be really useful and save us valuable time. There is a lot more to the study of Pythagorean triples than just spotting shortcuts on tests. Although they are named after Pythagoras, who lived about 2,500 years ago, the first example we have of people writing them down is almost 4,000 years old, and they continue to be relevant to math that people study today. There is also a formula called Euclid's formula for generating Pythagorean triples from any pair of integers. We won't get into this here, but you might be interested in exploring it on your own or with your teacher. Thanks for watching. I hope you find this helpful.